So we're going to start right on time today because we've got a lot to cover. This is an essential topic for this whole course, which is you can go learn about AI in those other classes. You can learn machine learning algorithms and optimization and what hyperparameters mean and so on and so on. This class is about people, about how people understand AI systems and what AI systems do to people. So the title here is Fairness, Accountability, Transparency, and Ethics in AI. And I called it that because it stands for FATE. And there's a major conference in this area called the FATE Conference. And so if you're interested in this kind of stuff, I encourage you to go look up that conference and what they're doing there and the papers they publish there. That's the sort of latest work that's going on in the field. So, there we go. Let's start off with the AI news of the day. Always the most fun segment because you get all kinds of interesting things, including, for example, incredible failures of AI systems. So I'm going to pick on Tesla today. This is Tesla in full self-driving mode, or sometimes not. So what you're seeing here are two Tesla crashes caused when the person was in full self-driving mode. And the Wall Street Journal recently did a big report on this. They did it middle of last year, trying to understand what's going on here. So this picture on the right here is particularly interesting to me because it happened right in front of my office, and this caused, as you can imagine, a huge mess. In this case, that was a Tesla with a Tesla engineer inside of it driving to work, and it went into the center median and wiped out the car. I wanted to also show you this little clip of video because there's nothing quite brings it home quite like watching through
February
the camera
27th,
of
2021.
So this is
Police
this little
body cam
fragment here
footage
is body
shows a
cam
traffic
from the
stop on a
police
highway in
He
Montgomery
stopped that
County,
person on the side of the
Texas.
freeway. Again, this is in
As this
Silicon Valley. This is
2019
now the
Tesla
view
Model
from the
X
Tesla
driving in
as it
autopilot
drives full
mode
speed
strikes their vehicles
into
at
this police
54
cruiser
miles per hour,
and has a bad consequence.
injuring
And
5 officers
the
and
interesting thing
hospitalizing the
here
subject of the original
is
traffic
understanding
stop.
why did this happen. So from the human perspective, what should you take away from this? Number one, don't trust full self-driving mode in Teslas, right? Number two, don't get in a car that doesn't have full level 5 autonomy, right? That's just sort of an obvious thing. So I do think it's probably due to them having inadequate sensors. Now, as you probably know, Tesla is promising to do a fleet of taxis, self-driving taxis, much like Waymo. I'm not sure I'd get into one. Partly because they just don't have enough data. They're relying totally on cameras, whereas Waymo has, as you probably know, about 6 additional LiDAR sensors. They've got radar. They've got a fleet of other vehicles that are sending and integrating data together. So they have a much richer data set, which is why their accident rate is so low. But this is sort of tragic. So in other news of the week, the LA Times, the big paper in Southern California, recently published, had their AI bot write a little op-ed piece defending the KKK, which in the US is a well-known hate group, which is something you don't want your paper to do. It's a bad idea, right? And part of the problem here is it was just hallucinating without oversight. So this is one of the lessons from this entire class is AI is great, it's wonderful. Watch it. Don't let this stuff run unimpeded. In a couple weeks, when we talk about agents, we'll talk about letting agents just run wild and do whatever they want. I think that's a tremendously bad idea, at least at this point. So that was a huge mistake. But in an upbeat one, because I want to leave you a positive note here, there's a bunch of AI design systems that are out there now, and there's one that came out recently, reported on in Nature, which creates these chip designs which are so complicated and so weird that no human understands them. You knew this was coming. You knew this was coming, right? So this has been true for a while now. Simulated annealing systems, for example, can do optimizations and create chip designs that I look at it, I have no idea, and no human can understand it either. And the problem with that, as I mentioned before, is you can create AI-generated designs like this car chassis, that was generated by an AI system that minimizes weight, optimizes strength, so on and so on. But once it breaks, you can't repair it. It's right at the edge of survivability for a mechanical system. And the problem with that is that if it does break and you're in the middle of the desert, what do? Do you know how to fix it? Is there a way you can understand the system well enough to be able to repair it? I know what you're going to say. Dan, get another AI system to repair it. Wait a second. We can't go down that staircase forever. So anyway, I wanted to just bring those up to you. And today we're going to talk about assignment 3, okay? So let me click through to this. And it's handed out today, officially. And it's basically what's called the Wizard of Oz study. We did this last year, and I was talking to a couple of the students from last year, and they thought this was like the most interesting assignments because it's so much unlike anything you've done in any other class. So here's what it is. I want to go over it with you real quick. The Wizard of Oz, well, this picture is from the 1938 movie Wizard of Oz, where the wizard is that guy here behind the curtains who's secretly making everything happen. He's moving the levers and speaking with a loud, godlike voice. And Dorothy and the Tin Man and et al. Have discovered that. So in assignment 3, we want you to do this. The Wizard of Oz technique is a well-known technique for simulating an AI system, but then watching how the human actually reacts to it and understands it. So what you do is you set up some super user here on the right-hand side, who either talks or texts to the unsuspecting subject on the left. So what you do is you recruit someone, you say, hey, we have this great new AI system. It will text to you about, I don't know, classes at UZH. What classes should you take? Or you get to pick your topic, whatever the topic is. You want it to be an expert, okay? So you set up a system like that, and then, and I recommend actually going and reading this sort of classic paper from 1983. I mean, yes, this is actually really still relevant. It says, with a partner, you need a partner. You need a partner. It doesn't necessarily have to be somebody from the class, but I highly encourage that because then you get 2 reports for the price of 1. So the 2 of you can work together and you return in 1 report. You both turn it in the same report, but that's fine, right? So that way you can actually work together. What you'll do is set up one person in a room next door, not with the expert. The expert and the participant then text back and forth answering questions just like a chatbot would. Okay? If you want to go in wild and build something else with interactive graphics and all that, fine. Careful, you still need to turn it in 3 weeks, right? People have gone wild. You have a question? Okay.
It's 3 weeks or 2 weeks?
Well, it's the 25th. Today's the 11th. So you're right, 2 weeks. I can't add either. So anyway, so you want to set that up. You got 2 weeks, and basically here's what you got to do is create a video summary of your findings. Make a little Google Doc, that's what you'll turn in, but embed the video in there. Say, blah, 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 this is John and Bob, and we did the following thing, blah, 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 real quick. Here's a short video. Anybody uncomfortable making a 5-minute video? I'm talking to the TikTok generation. I know you can make 5-minute videos. Okay? So you'll make this video sort of documenting what you did. So everybody turns in the same document, the same video. Here are a bunch of ideas right here. So if you can't think of something, go click there, take a look. Again, you'll use this link to turn it in. New. Add as an editor of your document this email address. Okay? HCIAIZRH@gmail. The reason is that we have now 4 people grading. Okay, so Ibrahim, who you know, me, we've added Izia, who took the class last year, and Chat, who is not here today, but he often comes into the class. So he's my office mate. So we now have 4 different people. And rather than having you give edit permission to 4 different people, which is kind of a pain, give it to that one email and we can all log in. Okay? That makes sense? Yo.
Is it safe to put edit or privileges to anyone who has a link?
Yes, you will have achieved security through obscurity, because nobody's going to figure out your link, truthfully. So you could say anybody, yeah. But if you do this explicitly, that'd be fine. I doubt that you're going to be, your assignment 3 is going to be hacked by somebody as a way of getting into your bank account. No, so that would totally be fine if you want to do that. So that's assignment 3. Does that make sense to everybody? Yes?
Question. So when we run an experiment, it's not for us to do this with one individual. So like we need to, it's okay to have just one participant.
Yes.
Okay.
Yeah. You can do it in a group of 2. So there's one experimenter and one participant. That's, you do need to. And the reason I'm going to all this is because students in the past have tried to do it sitting side by side. Don't do that. You want to separate them. And the point of this whole exercise is so you can then analyze. You can talk to the participant afterwards and say what worked, what didn't work, what you were thinking, why did you think that crazy thing, et cetera, right? Ideally, the participant will not know it's a human, okay? Question?
Just a quick question. You said 5 minutes. It says here 1 minute. In 1 minute, we have to tell everything.
1 minute. Where does it say 1 minute?
In my version, at least, on
Yeah, it says
page 3.
on the 4th paragraph.
A 15-minute study, okay. We're gonna, I see, a 1 minute video. 1 to 5 minute video. How about that? Thank you for that. If you can do it in 1 minute, great. I'd be surprised. Like I said, I'm not going to ding you if you go slightly over. Do not turn in a 15-minute video, because 15 minutes times 100 is too much video. I can't watch that. Okay. There are 100 of you. Okay. So that's assignment number 3. Assignment number 2. I asked, in this case, ChatGPT, to generate a medal that says AI news you can use. Now, you've all done this assignment, right? Did you also have this problem?
Yes.
Right. That's the big point of that assignment, is Gen AI is great at many things, but getting text right is not one of them. How many people actually got the text to generate correctly? Anybody? Okay. Okay, well, you already knew, right? So, yeah, those little details are really problematic. We'll talk about this more in a little bit, but I wanted you all to realize that was one of the big points of this. Luckily, there's only 4 fingers here. Sometimes you get 5, 6, 7 fingers. You know, those kinds of things are not modeled in the sense of you have a physical model. One of the big efforts in AI today is how to build physical models, 3D models of things to generate against. But we'll talk about that later. Okay. Again, orientation. We are here. This is week, what is it, 4 now? So we're talking about fairness, accountability, and so on. And tomorrow, Ibrahim will be here to talk about explainability. So this will be, I guess, the 3rd, or this will be the 4th lecture on some aspect of ethics in AI. So I want to make sure you leave this class understanding a lot about this, because this is important stuff. Okay. So in the vein of doing AI stuff, I took the slides from this lecture, and I gave it to Gemini and said, create me an outline for the horse, for the class. Generated this. Gave me this free robot picture. Like, okay, fine. I want you to think about this, because bias and fairness effects start right at the very beginning. So this seems like a simple thing. It was a click away to generate this outline. And yet, oh wait, at the very end we'll talk about what's missing, right? So think about this. What was missing in your generative AI images? What's missing in this outline? This looks really good, right? And this is the problem. It looks great, but it has problems. So let's talk about the problems of bias and fairness in AI. As you know, AI systems can have a big impact in society. It's obvious. We want to maximize benefit and minimize harm. We want it to be fair. Okay, what does it mean to be fair? So we want people to have confidence that it's fair. It's one thing to be fair, and it's another thing to have people believe it. Right? and we want people to have recourse, that is, the ability to question. So tomorrow's lecture about explainability is a big part of that. Can you, for example, click into your AI system and say, why did you make that choice? And have it generate an explanation to you. That's what recourse means. So now when we think about fairness as an issue, we can frame it as a technical problem. Is this thing fair? Is this game fair? Right? Is it biased against me? So if I think about dice, for example, if it always comes up 6, something's funny, right? There should be a distribution, right? So fairness in some ways is a technical, statistical problem. But it's also about making the model better. And it's, in some sense, you can think of it as a data scientist task. But I would say it's a socio-technical problem because fairness lives in the hearts and minds of people who are experiencing it. It's a socio-technical problem because we have to, in social groups, understand what fairness is and how to define it. It's also about mitigating harms. It's not just about improving your model. A data scientist, an ML engineer will say, well, we just have to improve the model. I would say, no. We have to understand how to make the harms less. How do we have an effect on the person using it or the group using it? And it's more than just the data scientist. Key takeaway from today is it needs user research. You need to be thinking about that. And data scientists are part of that. But also think about the social effects of what fairness means in your AI systems. So there's, this is that conference I was telling you about, the Fairness, Accountability, and Transparency Conference, also called FACT. In other versions, it's called FATE. But there's this huge conference all about this. Go find out more there if you're interested. So let's get some definitions on the table. Okay? So fairness, think about it to yourself. How would I build a fair thing, right? If you're creating, for example, a game that plays blackjack or poker or something, you want the cards to be distributed evenly according to statistics, right? What we mean in the AI world is mostly that the models you make and use are not biased with respect to whatever those are. For example, gender, race, religion, age, ethnicity, et cetera, right? It should be accountable, and by accountable, I mean it's possible to identify responsibility for design or for choice or for an action. It should be transparent, and this is the explainability part. The system should be able to, the user should be able to understand why a decision was made. Trust is that the people using the system and the stakeholders can see the system's accurate, fair, and accountable, right? Now think about this. They're the users who care that it's fair, and the stakeholders, and they're not the same people. The stakeholders, the people in the company, or the regulatory agency, or the government writ large. They all care that these things are fair and so on. Let's take an interesting historical perspective on this. So we can think about what other areas, other disciplines have done. So in the 30s up to the 70s, which is a scary long amount of time, in the US there was the infamous Tuskegee syphilis experiment, where these people were all black farm workers, were all recruited to be in a syphilis experiment where they intentionally gave them syphilis. Here, get this shot, boom, you have syphilis. And then they, what? Question?
They were not intentionally given syphilis. They were really never informed that they had syphilis and never given treatment.
I'm getting there. You're one step ahead. So they were given this mysterious injection, right? And some had syphilis and some were not. And then they were not treated, even though it was very clear what the treatment would have been. Basically, their antibiotics cure it, no problem. And so the process was to let this go forward. And this was a huge, actual unfair harm because there was not informed consent. That was your point. There was not informed consent. So a little bit later, the Belmont report came out. The Belmont report, in talking about doing experimental science with human subjects, is that you have to have 3 properties. There has to be respect for the people, respecting their autonomy, and so on. Have integrity about this study. You have to have not just a philosophy of doing no harm, but maximizing benefits for the research project. And third is make sure everything is administered fairly and equally. Okay? So that's a pretty well-known report. Lots of people have signed up for that. A little bit later, that was 78, a little bit just before that, there was the recombinant DNA research agreement at the Asilomar conference. So Asilomar is a place in California, and picture here is a bunch of biomedical researchers got together and they said, this recombinant DNA stuff is getting out of hand. We need to put limits on what people can do and will do and so on. We don't want, for example, part of the thing here was we should allow recombinant DNA organisms, we should require that they be contained within a particular kind of lab, and a description about what labs are acceptable. They did not want to allow bioweapons to be created, and so on, so on, so on. So here's the good news. This kind of worked. A bunch of people got together. They established this worldwide protocol for doing this kind of particularly dangerous research. So one thing to keep in mind, doing, at the time, in 1975, doing this kind of research was complicated and expensive. You needed a particularly high-grade lab with really great quality machines and reagents and so on. So it wasn't like you could just do this on your laptop in your bedroom at night. The world is different now, right? In 2000, in the US, there was this wave of starting what are called institutional review boards. An institutional review board is a body at a university that gets together and approves or not your human subjects experiment. So if you go to me and say, I want to do a study with 1,000 people, you have to describe what it is. The review board then looks at it and says, yes, that's okay, that's fair, that's safe, and so on. And the IRB, as they're called, was established quite a while ago, and basically its goal is to be fair to the human subjects, so requiring informed consent, not doing harm, and so on. And then in 2021 at Stanford, we added another layer on top of that, the Ethics and Society Review. Why do we need a separate one? Because the Institutional Review Board didn't talk about harms to society. We now see that with apps that gain 1 million users in a week, we can harm society by doing these large-scale experiments. So the ESR is an additional layer that thinks specifically about how experiments can harm society. Trust me, you have been in such a study. You may not know it. All of the major companies, Facebook, Google, Amazon, so on, all run experiments constantly. Some of them would not pass the ESR's test. So for example, a few years ago, Facebook ran a big study where they tweaked the order of results to see if there was what was called a social contamination effect. And they ended up changing the results when you went to Facebook of what you actually saw. That would not have been approved by this board because the effects, for example, on political decision making would have been too high. Question?
Isn't it like one of the official guidelines that citizens must be informed that they are partaking in this
Yes,
study?
yes, that's exactly right. You never saw that announcement, did you? If you were using Facebook in the past 10 years, you were part of the experiment. Yeah.
Probably maybe in terms of service?
Exactly right. So oftentimes they will embed in the terms of service, which no one reads, right? That we reserve the right to actually alter the results and so they put all that language in there after they caught a lot of flack for doing these studies without informing people. That's right. So that's what ESR is about. And we have, when we talk about these studies, we talk about protected classes. And a protected class is one that is identified as a class of people that needs particular support or protections. So we're worried about having different classes with different kinds of treatments, so disparate treatments. So you have effectively intentional discrimination. And we have different impacts based on that. So we're trying to figure out how we can be fair, recognizing that we have to work within protected groups. Right? So in the US in particular, and Europe has a similar thing, there are particular classes of people that are identified as being protected for various kinds of purposes, including research purposes. So this was, those usual sort of race, national origin, religion sorts of things. But then these were added a little bit later: age in 1967, gender in 1972, and disability in 92. So these are all now, when you make your research plan, you have to say why you're not overtly impacting one of those protected classes. Yeah.
Is this still valid?
Yep. Kinda. So the question is this still valid? It is still a recognized concept. The question really is it enforced? And it is enforced unequally. I would say these protected classes protections are not quite as universal as they were, say, 5 years ago. So the problem is law changes, but this is what it was as of, say, 2 years ago. So one effort that was made not so long ago was to basically say, hey, AI, all that stuff that's going on is going too fast, we can't control it, we don't understand it. And so a lot of people, 12,000 people, signed this letter asking the big companies to pause. It had zero impact. It was basically a political stunt to basically allow people to say, hey, we're concerned about this. We see these are the problems. Following the Asilomar principles, we're going to basically say we should not be doing this research into, for example, deep reasoning models and so on. We should not be doing research into agent systems and so on. It had all the effect of throwing a BB into the Grand Canyon and waiting for the echo. Did not happen. But it put people on notice that this was a concern. Right? So then there's this famous paper, which is in your reading list, the Stochastics Parrots paper by Tim McGrew, Emily Bender, Angelina McMillan-Major, and Margaret Mitchell. They're basically in this paper arguing that large language models have a particular nature, which is that they are stochastic parrots. They don't actually reason. We'll talk about what that means later. But the deeper point here is they were trying to get people to say these are really interesting issues and the government should be taking active regulation. Now, in the last administration, 2 months ago, there was an active regulatory process to limit what could happen with AI. And in the current administration, as far as I could tell, they're throwing all that away. So what's going to happen? I don't know. But any notion of regulation from the current administration in the US is basically gone, which means we have to rely on Europe now, which is going to cause a problem. This is just a prediction. As AI systems in Europe get increasingly regulated and AI systems in, say, China and US are increasingly unregulated, it's going to create this huge disparity. So stay tuned. So let's talk about AI principles for just a second. And what I mean by that, the Asilomar conference was held for biomedical engineering back in the 70s. This was a more recent one. And in fact, my co-instructor here, that's Peter Norvig right there. He was standing there as part of that thing. As you can imagine, the whole problem of this conference was to basically establish AI principles that would be useful going forward. And they came out with a useful set of principles, but again, even though all these companies have signed on to it, apparently none of them are actually following them because, a lot of companies you may know about. But let's talk about what those principles were. So I'm going to say this is aspirational at this point. This is what we want. How do we get there? We want AI systems to be socially beneficial. We're going to keep coming back to this point. It's easy to build systems that are socially damaging. How do you build one that's socially beneficial? We want to avoid creating or reinforcing unfair bias, particularly in protected classes. We want them to be built and tested for safety. Again, this is something that's done right now with red teams, but not a lot of testing for safety is going into these systems. For example, the Tesla I showed you earlier on. They need to be accountable for people so that when an AI system does something, I know who to call when things go wrong. Okay? We need them to incorporate design and privacy into their design, fundamental privacy principles, uphold standards of scientific excellence, and be available for uses that follow these principles. Okay, so fairness. So that was principles. Yeah.
Wouldn't it also be true that those companies have to be non-profits, like OpenAI was?
No, was is correct.
Was?
Yeah. OpenAI is an interesting case because they were set up initially specifically to be OpenAI research, open in the classic sense of open. They quickly pivoted and became for-profit, and they still technically have a nonprofit wing, but it's getting smaller and smaller by the day, so it's going away. So they're now a for-profit agents group. That was the idea, but the lure of $1 trillion was just too much, and so they switched to a profit. Yeah. So I've got a ton of these. There's lots and lots of examples of machine learning AI systems that have gone wrong, primarily as all these headlines show you, instances where the machine learning algorithms all kind of went bad. So the one we're going to talk about machine bias at the very end with ProPublica, but this is one that's really interesting. So not too long ago, Microsoft introduced an AI bot called Tay. And what happened was that Tay had this really interesting property. It would learn from the people it chatted with. Okay? Now what could go wrong? What could go wrong? Any ideas? It very quickly turned into a racist, sexist, ranting bot because it was basically echoing back all the stuff it was picking up from all the tech bros who were talking to it. And they're almost completely men, but that's a separate issue. Nevertheless, it learned very quickly to be incredibly aggressive, incredibly sexist, and disparaging to protected classes. So within about a week, they had to turn the whole thing off because it was getting out of hand, turning it into a public relations nightmare. Lesson number 1, careful when you let systems learn from open chat channels. That's a sure way to make your bot or your AI system very, very sketchy, shall we say. So let's talk about fairness then. Here's the fundamental insight in many ways for this class, is there's no one true definition of fair. You might think naively, oh, we'll just build a fair system. And then I say, okay, tell me, what do you mean by fair? What do you mean by fair? Or you can't even define not biased or morally right, and so it's difficult. We'll talk in detail what I mean by that, but it's really hard to do this kind of work. Give you an easy example. When is it okay to lie? Just person to person, when is it okay to lie? We all tell lies. It's just true, right? Sometimes we call them white lies, little white lies. They're not important, it's just a little white lie. I really came back, I didn't go out to that bar last night, right? And sometimes white lies are actually ethically justified. So for example, if you have a parent who has dementia, who doesn't remember that their spouse passed away last year, should you tell them every day that they passed away because they will then re-experience grief all over again, right? So in elder care, patient dementias, people who can't remember things, it's often common practice just to say, they'll be back soon, don't worry about it. Otherwise, they go through this grief process every single day, and that's damaging in a whole different way. So often, white lies are the correct thing to do. So what do you think? Give me another example when it's appropriate to tell a little lie. I just gave you one about dementia. What would you say?
When I was late to class.
Pardon?
When I was late to class.
When you were late to class. Why you couldn't make it in, right? I had one student whose grandparents died 4 or 5 times. It was impressive. Anybody else? When's it appropriate to miss? Yeah.
You tell children that there's 9 planets.
Say again. I couldn't.
You tell children there's 9 planets.
Very good. Very good. All right. So one possible definition of fairness, you might say to me, Dan, it's the absence of any prejudice or favoritism towards individual or group based on the inherent or acquired characteristics, right? So let's talk about, if you do a Google search in images for professor, this was a couple years ago. Notice anything interesting about this? What's the bias effect here? What? All men. Do you know what the actual ratio, gender ratio is in the US for male-female professors? It's 50-50. Or very close to it, like 49-51. It's super close. This is totally not that. So let me tell you, AI fairness engineers, what should Google do? Recommendation?
The solution would be to just force it, and the good solution would be to look why it happens.
Right.
Like, for example, if it's all LinkedIn images and
Right.
more men use LinkedIn, for example.
Right. Very good. So one solution would be, let's force it to be the actual ratio. Okay. And this is another question. Here we have stock photos, which is even worse, even more masculine. Here we've got a more recent one, and all of a sudden, women start to show up in much larger numbers. So that's in fact what happens, is that Google has said, we will adjust the gender ratio to be whatever, right? Now that's interesting. Okay, we'll do that. What's the gender ratio, say, in Greece of faculty, male, female? It's very different. Should Google adjust the gender bias for each country? Each canton? Where do you draw the line? So people in product decision-making roles have to make those choices. So at the moment, they do it nation by nation. This gets even worse if you look at image generation systems. So you all know there are systems like Crayon that will create synthetic people. And we get the same problem. In fact, it's even worse. It's not a single female faculty member. Hypothetical female faculty member. We don't generate women. Right? So what would be a fair response? As you suggested, we should generate the pictures that reflect reality as measured by gender samples on the ground. I will also tell you that if you look at actual numbers of pictures, of actual images, you get more men than women for faculty. So you have to distort what's true in order to be fair, right? So do you represent different kinds of groups? For example, what about race or ethnicity? So we have to think about what counts as a group. Just protected groups or other groups? For example, left-handed Lithuanians. Do we have to represent them in there too, or? Okay. So what counts as a group? This is our first discussion for just a minute. I'm actually not going to give you 5, I'm going to give you 3, but I want you to come up with what defines a group. Go. All right, all right. I'm awaiting your wisdom. I'm looking for your answer. What defines a group under this criterion? Any ideas? This is where you give me the answer. Yes.
Said a collection of people who share one common trait.
One common trait. That's a good one. Anybody else? Back rowers. Looking at you guys. What would you guys say back there? How many people asked ChatGPT? Yeah.
Not that, but so we started with saying, I don't know, like it was like a minimum of 2 people to share this common trait. Like it could be
Oh, okay.
2 people.
All right, so it has to have some minimum size.
Yeah.
2 is, by definition, the minimum. Okay, if you now let me ask you a pragmatic question. As a product manager of some AI product, what size group do you care about? Is 2 the group you care about, or do you care about 2 million, or do you care about 20,000? Where does it make a difference to you? Have a thought?
I think the defining characteristic isn't like per se its size. It's more like the fact that, like some subset people has like a shared group identity, and more most likely has been like subject to like some kind of historical discrimination.
Okay, okay, that's different than trait.
Yes.
Right. So there's some shared identity,
Yeah.
and perhaps some. And a separate concept is they've had some discrimination in the past. Yeah, you have a thought.
Kind of also depends on how specific the trait is, I would say. Because
Right.
like when you said the common trait is being a human, then all would be a group.
Right, 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 right.
Say it's a very specific kind of.
Yes.
For the project manager, then I would say let's look groups that felt discriminated before and vocally spoke out against, and then just
Uh-huh.
take those as a list, and if someone else speaks out, then let's add them to the list.
Okay. So they
Project manager.
they actually had to have spoken out, so it's visible to the product manager.
Yeah,
Yeah.
so
Good.
if you don't speak out, then
You lose. You're not represented. Yeah.
Yeah, if they
Okay.
don't say anything, you can't look at them, like,
Right.
especially for them.
Right. Yeah, that's actually a non-trivial point, which is if you can't identify them in some way because they haven't spoken out, there's no identifiable trait, or they're not a social group, what can you do? Right. Yeah.
From a product management perspective,
Yep.
I would just look at the effect it would create.
Ah.
So when you consider that group,
Okay.
what kind of effect it would
Yes.
bring back.
What kind of effect does it have? Yeah, very good. So in the case of Google, of image search, where you're doing some either image synthesis or retrieval, non-visible traits are very difficult to sort by, right? Is left-handedness a discriminated trait? We know it is because left-handers tend to have more injuries and so on and so on, but I can't tell from their picture if they're left-handed. There's no way to tell. So it's very difficult to do anything about that. So we get biased outcomes, and I'll tell you, when you build an AI system, you typically do not write code like this. If the professor in the query, then you don't fetch, stale, pale, and male. There's no code like that. It's in fact because the training set has a bias in it. We're going to talk about all the different sources where bias can creep in, unfairness can creep into the AI process. But this is number one. If you have a crummy biased data set to do your training of the model, you will get crummy biased outputs, behaviors. So, key point for today is that there are really a zillion different things that cause bias, and I'm going to show you a whole process flow so you can get a sense for it. But these are the top 6. Question?
Has it been proven that you can create data set without bias?
Yes, you read ahead. Excellent. Yeah, it's basically impossible to create an unbiased data set because there's always different factors, different traits, different things that you haven't thought about. So you can collect, for example, the best image data set, and then someone later will come along and say, well, you didn't think about this, and they would be right. So it's really tough.
So you can create a data set without bias?
You can create a data set that you believe is, according to your current definitions, unbiased, but the definitions can change.
Is that like a rating you can set on a data set that says like your data set is like 10% biased?
Yes, we will talk about things called model cards, where people explicitly declare, here's a data set and it has the following known biases. Okay, so that anything that's not listed is something they haven't thought about. Okay, so here's the key diagram you want to know for today. We're going to come back to this multiple times. But the canonical AI system goes through these different phases of the process. So there's data generation from the world. You then select a set of that data to create your model. You then measure that data in order to do pre-processing, post-processing. You then evaluate the system as it comes out. You aggregate different kinds of sets of data together, and then you deploy the system. So this is basically from soup to nuts, your AI development system, from very beginning to very end. Right? And I should point out that each of these 6 labels here introduces its own kind of bias. We're going to unpack each of those in a second. There are others in here, but these are the top 6. Bias can creep in anywhere along this cycle. So, for example, the world we live in has all these biases for and against different demographics. So, for example, accurate data could still be mistake because of history. For example, in the US, Native Americans, African Americans have been historically biased against various policies and so on. So, for example, take an easy case. In 2024, 10% of the Fortune 500 CEOs were women. If you search for CEOs, Fortune 500 CEOs, should you only see 10% women? Or should we proactively be pro-social and represent more women? So here, I went to Microsoft Bing and I said, show me the Fortune 500 CEOs. Okay, women are overrepresented there. Black people are overrepresented there. But Microsoft has made this conscious decision to bump up the numbers in order to present a more pro-social appearance of the data. So this does not represent the underlying population statistics. All right? Yeah?
What about the recommendation that says black CEO, female CEO, Fortune? That's overrepresented as well, right?
Yeah, I thought I just recognized that's Marissa, it's a friend of mine. I literally didn't see that before that. Yes, there is a distinction here called out by race and black and female and black again. So yeah.
That's too much, right?
Well, yes, it is too much. On the other hand, this is a different process than this. So these are recommendations, suggestions, and they're aggregated a different way. Yeah.
Do we know if they ever try to find out the underlying cause of the bias?
Yes, everybody, both Bing and Microsoft and Google and Amazon all understand these population statistics really well. So it's very conscious. So representation bias, that first one, is when the training data we collect does not contain certain subpopulations. We call that representation bias. So for example, if you collect data just from smartphones, you don't sample the older population who tend to not have them. If you look at something like ImageNet, which is this big image data set, 45% of those images were taken in the US, 1% and 2% came from China and India, so you instantly get a kind of biased sample against China and against India. A very famous one was this 1936 presidential election where the sample was drawn exclusively from readers of high-end magazines, and so lower class population was never sampled, and they voted overwhelmingly for Harry Truman. So it was a famous mistake of sampling because of representation bias. Then, of course, there's another problem. If you just go out and collect data, you would think, well, I'm collecting unbiased data because I'm sampling everybody. But let me tell you, some groups love to contribute data. They love it. This group, for example, in the US, undocumented immigrants, hate providing data. They just hate it. So they're always undersampled, always, by significant numbers. And so when you're thinking about these collection strategies, right before you even run the first AI model, you have to think about how the sampling is different by different groups. So when we measure these things, you have to realize as an AI engineer that a lot of the signals you're building are really proxies. A proxy is something that doesn't measure the quality you want to measure directly, but measures an approximation of it. So if you want to, for example, figure out how much financial responsibility someone has, you look at their credit score. I will tell you, the credit score is not great, but it's better than anything else we have. So a proxy is usually an accommodation. It's something we do because we can't measure the real thing. So if you want to measure the real crime rate, what you do is measure the arrest rate. If you want to measure intelligence, you use in the US this thing called the SAT score. It's the standard test you take at the end of high school. So you have to be able to understand what biases are encoded or built into these systems. So it gets worse. If, for example, you want to measure something that's just completely objective, like the productivity rate of people working in an industrial factory, like how many light bulbs per hour can a person make? So it turns out that if you just monitor people, I'm watching you, just doing that, just telling people you're watching them changes their behavior. And all of a sudden, they start producing more. Nothing has changed other than the fact that I told you that you're being watched. Okay? So the sampling process itself causes a bias. If you've got 1 million people and you tell half of them we're going to collect your data, and the other half you don't tell them, but you collect their data anyway, you've just biased half your sample. So, for example, women are more likely to be misdiagnosed for pain symptoms. It's just the case that women who walk in the emergency room say, oh, I've got a pain here. You know, it's like, yeah, whatever, you're fine. And that's a culturally built-in response. Black women get even worse deal. They're misdiagnosed at an even higher rate. So there's all these different interesting issues about where your data comes from and how you get samples. Okay, that's the first two things. Bias could come in when you aggregate data. So for example, HbA1c blood levels are commonly used to monitor diabetes. It's just something, a chemical in your blood, you measure that. But that level varies depending on your gender, your ethnicity, your historical background. It depends on a lot of things. And so just clumping all the HbA1c levels together will give you a very distorted picture of this. So these are issues you have to think about early on. What are the bias effects that come into your data? For instance, ChatGPT was trained on what? A lot of the English language literature, right? And a bunch of copyrighted content that was grabbed from sources, right? We don't know, I don't know, what the relative language breakdown is. I don't know how much of that was Chinese, how much of that was German. I don't know. We could sample it and try to figure it out, but I don't think they cared. They just grabbed everything they could get, right? So aggregation bias now happens. You got all this data. We know we've tried to avoid all the big biasing effects. And so we aggregate it together. Now, here are two charts. Let's just look at the one on the left for a second. If you just aggregate all the data together and run your standard multivariate linear regression, you get that nice red line. You think, awesome, right? If you're very clever and you recognize that this data comes in clusters, you can get very different answers. Those are the green lines, right? If you aggregate all that stuff together, right, and with respect to clusters, you can get cluster regression and see that wavy green line. But you're an idiot if you didn't notice that there are natural clusters here. A data scientist would look at this and go, oh, these are obviously 3 clusters here. Let's analyze them separately, okay? Not just aggregate them all together. I cannot tell you how often this error happens in industry. I've got a data set of 5 billion pieces of data. I'm just going to run my regression statistics over all of it. And I would say, hey, did you actually look at the data? Did you do obvious tests? for clustering and groupiness and all those standard kinds of things. No, I just ran the regression. Don't be that person. Look at the data. This is the thing I tell all my data science classes. Look at the damn data. Because so many times people will just say, oh, it's a data set, I just import, boom, we're done, right? No, take the 5 minutes and actually look at the data to avoid exactly this kind of aggregation bias effect. So evaluation biases come in when you try to actually measure the effect of the data you've got and the tests you're running. So benchmarks, right? You benchmark the data. We use them to look at the data set and tell us how well it's performing. So it's often common to report accuracy on these things, but if we look, for example, at face reco systems, they often perform much worse on darker skinned people. Because guess what? What were they trained on? Americans and Northern Europeans, right? So all of a sudden, accuracy has to tell us, we have to start thinking about how do we evaluate these things with respect to different populations. And the last sort of big source of bias in these things is deployment. By deployment, I mean we're going to put this AI system out in the world and we're going to run it. And you might think, hey, I'm done. How can bias creep in then? Bias creeps in because we have differential application of the AI system in the real world. So we'll talk in detail about crime risk prediction model, but they might be calibrated correctly, but they probably are not used correctly in the courtroom. So there's actual use in deployment. So for example, X-ray analysis models may not be accurate across different hospitals, different populations, different devices. For instance, Google built this really marvelous device that would look at the retina in the back of your eye and then help make a medical diagnosis, particular problem, high blood pressure, diabetes, so on. Great. How could this go wrong? Deployment. It works really, really well when you've got this device and you use it in a clinical room, a clinical setting in a hospital in the United States. Hospitals in the US are very clean, they're very uncluttered, nothing goes wrong, it's very all monitored and so on. If you're doing that same device in a field nursing station in India, it's a different thing. All of a sudden there's a lot more dust, things get reused and misplaced, data gets misreported. Deployment matters a lot. And so you may have a device which works according to my measurements really, really well. But when I put it in this setting, all of a sudden things act very differently. That's deployment bias. So this is the summary here. We have all these 6 different sources of bias effects, what causes them. And I told you, I think, how to start thinking about this in a coherent way. This is the perfect slide for us to take our 5-minute break, okay? So let's come back at 5 after, and we'll start talking about confusion. Hello.
Change this here, this element, right? You come up with
No, this is, I decided to, I changed it back. So this is, it was originally the Wizard of Oz problem. I changed it to something else, and I changed it back.
Oh, so you decided
To stick with it. And the reason is that I talked to a couple, like I said, a couple of students from the last class. They said, oh, that was a fabulous assignment. I learned so much. So I decided to.
possible to do it not in the group?
No, not possible to do it without a group. You need at least one other person. It doesn't have to be a person in the class, but you can recruit somebody. It's harder to do it that way. But yeah, you can do it that way. You can recruit a roommate or somebody, a friend of yours or something, and say, I'm going to have you test my cool new AI system. And then you can record it.
A lot of effort from that person.
No, it's like 10 minutes at a time. And then, I mean, so you run the test, and you run the test, and then you would talk to them and debrief them afterwards.
Is it possible to do it alone?
Just recommend that. Yes, you can, but people who do it then by themselves don't get as good an experience. Why do you want to do it by yourself?
It's also because I'm exchange student, I'm
Yeah.
from here.
Yeah. Where are you from?
From Milan.
From
Milan.
Milan. Yeah. Ibrahim's from Milan. Yeah.
Okay. So therefore, I'm thinking.
I would not recommend that. Find somebody. So if you're having, I mean, we haven't got to that point yet, but I'll set up a spreadsheet where people can, find partners. Yeah. So you want to, don't worry about it yet. But when we talk about the final assignment, I'll say, anybody who wants a partner, here she is. She speaks Italian. She's great, right? Come talk to her. Yeah.
So you are a guest professor here. You're not from here,
Right. That's right.
So because I'm in the last year of my master's, and I was thinking about thesis,
Yep.
and I wanted to ask suggestions
Yeah.
from you about the thesis topics because I really like the topics that we are going, and maybe you have any ideas.
Oh, I have a lot of ideas. I'm happy to chat with you about it. If you want. Yeah. I can't be on your committee, but I'm happy to. Yeah.
You're not even from here.
I'm from Stanford, so I'm on loan here.
You're just going from coming from one semester here, right?
Yes, that's right. Well, yeah, because I taught this class in the fall semester 2023. Then I went back to Stanford all last year, and now I'm here for this semester too. And I probably will come back in 2026, but we haven't figured that yet. So
Maybe I'll come back that time to have these.
that'd be great. Great. But it will probably will be fall of 2026. So that may be too long for you. So
Okay, anyways, but ideas would be
well, what area are you going to do it in? HCI and AI, or just HCI, or do you know yet?
yeah.
Right. Yeah. Do you know Elaine Huang? Okay, you need to know her. She does human-computer interaction, and she does a little bit of AI stuff. She might be an ideal person for you to talk to about, being here and doing your master's thesis. Her office is right next to mine, so it's right around the corner. And she's a lovely person.
I still cannot do the thesis with professor from here because I'm not from here.
Oh, I didn't realize that. I thought you. So, where are you a student? Oh, I misunderstood what you said. Okay, now I got it. Okay. I have no idea how that works. Absolutely none.
But ideas would be.
Ideas, I'm happy to brainstorm ideas. That's it. Okay. Yeah, let's do that. Hey.
We have questions about the assignment next time. So first of all, we need the first participant, which is not part of the class, right?
No, it could be a field person in the class. It's better if it's not in the class.
I mean the participant shouldn't know that it is not an AI and it's a person.
Yeah, good thing. But it's better if we can get somebody not.
So that he actually doesn't know that.
Yeah. So are you all three together? Okay, you're all okay.
Yeah?
Yeah, absolutely. So you can be the participant and you can be the
I can do that.
Yeah, okay. Or you get another person.
You should not know that they are, ideally they should not know that they're also. I mean,
It's easier if you have two visitors and one participant. You need to participate. And someone makes it up. You built an AI system that does user recognition. And so then you're actually running the chat window and you're actually doing the Google searches in the background.
Like hypothetical findings that
I'm not going to tell you. You will find out. And everybody, almost everybody discovers that it's not as easy as they think. And and you learn more about what the expectations are for teams that can deploy the system, and how what you as the AI is supposed to do to change that. It'll be fun. We're gonna figure it out, yeah. That's why it's a problem, and not something just to be. Trust me.
That's very nice. This is to your degree, but also to your kind of career.
Hi, everybody. We're back. To follow up on a couple questions I got during the break, you can have a group of 3 in your Wizard of Oz study. In fact, if you can get 3, it's about the perfect number. Okay, so that's great. And when we get to problem, the final presentation, the final problem, I will go through that in some detail. And if you don't have a partner, I will help you find a partner. Dan's dating service. We'll figure it out, okay? But don't worry about it till we get there. Okay, to return to confusing topics, we all know what a confusion matrix is, right? It's that, right? And so it's basically the definition of true positives and false negatives and true negatives. You know about that, right? Now, I'm bringing this up because I want to talk about false positives and false negatives. So the famous British jurist, William Blackstone, said, "It is better that 10 guilty persons escape than 1 innocent person suffer." He's talking about, do we put somebody into the prison or not? Okay. Benjamin Franklin basically rewrote that slightly and said, "It is better that 100 guilty persons should escape than 1 innocent person should suffer," is a maxim that's been long approved. So it's been around for quite a while. So the question is, when you're making choices about judgments for crimes and punishment, how many false negatives are you okay with? How many false positives, right? Because these 2 guys are talking about false positives. Okay? So I'm not going to give you a long math talk. You can go read the papers about it. But I want to point out there are different ways, many different ways, to measure these binary classifications. So we can measure the error rate, comparing false positives and false negatives, the accuracy rate, the false positive rate, the true positive rate, precision, all this stuff. There are, 7 of them there, right? These are different ways of evaluating how good your algorithm is with respect to handling false positives and false negatives. So you can imagine setting up your system to maximize or minimize the error rate, but maximize the precision. And they will give you different answers, right? So what should we optimize? Let me give you an example from U.S. college admissions. This is not quite the way it works, especially now, but it's a nice example for us. One thing you have to know is in the U.S., everybody takes an SAT test at the end of their high school period. You go and take this test, it takes a long time, it's a long thing, and then everybody gets scored, it's fine. So if you think about success for college applications, it's somebody who gets into college and then successfully graduates. That's success. We'll define that. If we just use SAT score, we can talk about group fairness. We'll assume that everybody belongs to either circles or squares. Okay? Success or non-success. So your input for this is their SAT score. And then we get this variable indicating whether or not they were in the square group or the circle group, and the label will be whether or not they were successful or not. So we can define this f hat function that's a predictive model that says, given their SAT score, will they succeed or not? Right? So we give them a plus if they succeed, a minus if they predicted to fail. Right? Okay, so all we're trying to do now is we're going to create some definitions of fairness. Okay, here's the first one. We have groups, the square people. This side of the room is all square people. This people, you're all round people, right? So we want to admit without bias to either squares or circles. So either the left-hand side or the right-hand side. So one of the things we could do is to write a function, a prediction function, which is just f of x without taking into account the shape. So we call that shape blind or attribution blind. Okay? The problem is, as we discussed earlier, it doesn't work in practice because you're not taking into account all these other historic treatments or protected classes or any of that stuff. So what do we do? Well, we could say, let's admit people, whether you're circles or squares, so that we have statistical parity across the two groups. So we can imagine that we're going to admit just as many of you as we do of you, taking into account that property, gender, race, whatever, right? The good part about this definition is that it aligns with classical legal definitions. You do not discriminate on the basis of square or round, right? Doesn't matter. But as we're going to see, this is a pretty weak definition. So you might get more sophisticated. Say, here's the third one. We're going to provide equal opportunity to squares and rounds. So the positive rate should be the same for both groups. Okay? So this is actually trying to take into account a little bit more data to define what happens. We could also then make predictions. So we make a new function that gives you a probability, given that we predict you're going to fail, but you're in the square group. So we predict the outcome and therefore use that to backpropagate the likelihood that we're going to accept you to college. Okay? But it turns out I can go on. Right? I can give you definition after definition after definition of unbiased fairness things. And the problem is there are too many of them. So here's a table of some of the different approaches. And the question will be really not which is true, because they're all definitionally true. The question is which one works in the situation that you're in. So which one do you use? I don't know. Turns out that making decisions like this is what I meant when I said socio-technical system. These algorithms are all the technical part. The social part is trying to get people to agree on which one they want to follow. So the takeaway here is that discrimination and unfairness in all these choice systems, it's a problem we need to do, but we can't solve it purely algorithmically. Prediction. You will not see a paper in the next century that will say, here's the one true definition of fairness. It's not going to happen. So we need to involve all of our stakeholders, all the people who are engaged in using these systems as a way of giving input into how do we design the algorithm. I'm not going to talk about it here, but I'll give you a pointer if people want to follow up on an algorithm that fairly allocates kidneys for a transplant. So there are millions of people every year across the world who need a kidney transplant. Problem is there are only thousands of kidneys available. So how do you allocate kidneys knowing full well that you're not going to give kidneys to like half the people who want one? What's the algorithm you do to choose that? And there's a really great book about how they developed this whole algorithm with a lot of stakeholder investment. Really interesting book. Question?
How do you wait for the user? For example, let's say black people in the US they have like disadvantages. So for example, you have an algorithm which references black people, and the users see it and they see like, hey, black people are more black. How do you communicate with people that they have a disadvantage and that's why they are more dominant?
Yeah, I'm going to say that's part of explanation. But we'll return to that topic. Thank you for bringing it up, yeah. And in particular, to your point, I think people know about, how many people know about the Compass example? A couple of you. Okay, the rest of you, Compass was a model that was built by a company called North Point a few years ago, and it was used to predict the likelihood that inmates who were in prison would recommit a crime, and that's called recidivism. So, should we let you go or should we keep you in prison, right? So this was out, and it was used for many years, still is in use in some places as far as I can tell. And ProPublica, which is a news reporting organization, did this really nice analysis of this and said, oh yeah, it is biased against black people. North Point, the company, which is now called Equivant, they wrote back and said, no, it's not that. The scores are well calibrated, by definition of calibration, and they went back and forth and back and forth and back and forth. In fact, it's a really, if you're interested in this topic, reading the Wikipedia article about it is really interesting, because you can see the point, counterpoint, counterpoint, point, counterpoint, point, as they go back and forth about all this. So let me make this real. This is the problem. This is the problem. So we have two suspects here, two inmates. The guy on the left is given a low score, low risk of to committing another crime. The guy on the right is judged to be a medium risk. Now, if you look at the record for these two guys, here's multiple prior offenses. This guy's got one prior offense, right? You could see, does that make sense to you? A 3 versus a 6? So how did Compass come to make this choice? So the idea is that if the model rates you as a 6 or 7, you are 60 to 70% more likely to commit another crime, to recidivate. So this is what they said, is if you give a risk score by these two groups, it's within error here, is their argument. And of course then ProPublica says, well, that's not quite right because we get this very different kind of thing. We measure the reality of it. So North Point's algorithm, Compass algorithm, says, oh, this is our prediction based on our data. ProPublica goes out and measures it and says, oh, no, that's not what's happening. So bias has crept in somewhere. So ProPublica says the model is twice as likely to incorrectly recommend no parole for a black defendant. So something's bogus here. Something's really wrong. I want you to confront this. I want you to go ahead, and we're going to spend 5 minutes on this exercise, because I want you to determine, can you make choices better than a judge? Okay? This is better on a laptop, if you could do it on your laptop. But you can't do it on a phone. Ignore the ads. So you should see something like that, right? All the little red dots. Go ahead and read through that, and ultimately you're going to get down to a point where you can move the slider. As you're doing this, think about how could I, a human, do a better job? Or how can I build an AI system to do a better job? And after you're done with the red dots, make sure you get down to the yellow and blue dots section. Here, give you one more minute here to play with it. All right. You're now all the supreme judge of the country, whatever country. And your choice is to figure out how can we be as fair as possible to our inmates. And so in this version of the choice, what we're trying to do is, you can see we're measuring the accuracy here. So as I move the slider, it's 100% correct at this point, right? All of a sudden, if I go higher, it starts, so remember the solid dots are the people who were rearrested. So out of this population, these were the scores given to each. And then if we set it here, we jail all the people to the right. All the people in circles were never rearrested. So they were jailed sort of unfortunately. Okay. So now you can measure the accuracy, and what do you choose? So this is probably what the article says is the best threshold, because the accuracy is 69%. But no matter where you put it, no matter where you put the threshold, it's never perfect, right? There will always be people who end up being released and then rearrested, or people who should never have been in jail in the first place. So this is the fundamental problem. You, as a Supreme Court justice, have to be okay with a system that's going to make mistakes. Because this is true for humans as well, right? So let's go down to the next one. So let's move each threshold to see how it affects both black and white. So here now we separated out the white defendants in the top, the yellow dots, and black defendants in the blue dots. So the distribution here is somewhat different. Now, there are interesting bias effects here because of bias policing, bias stops, and so on. So if we move this here, we can see that the white people, that's released but rearrested, and Compass says we should do it here. But notice, even if I put them both at the same level, we get very different kind of results. Okay, what do you recommend we do? Take into account the severity of the crime. So a murder is different than a misdemeanor, for example. Yeah.
My thinking is, my preconception is that for black people, a lot of them are like minor demeanors, like theft or
Yeah, and they get arrested at a higher rate because of that. Yeah, that's right.
For
It could be. Could be. Any other thoughts? I like this because it makes very tangible for me what the trade-offs are here. So what the bias effects are become very, very clear. So I hope that was useful. So notice that if we do here, this exercise is, you can change the threshold to see how it affects black and white populations. But now if we move it so that they're needlessly jailed at the same rate, notice that they're very different. Notice that the best threshold for each group is very different. So one notion of fairness is we do not treat different populations differently. That was the very first definition I gave you. This is arguing, oh yeah, we really need to take that into account. Okay? As you know, a major problem for law enforcement is people come into the system and they don't speak the language of the judicial system. So in California, for example, I think when we publish, for example, the voting ballots, when California publishes the voting ballots, we publish it in many languages. I know in Switzerland there are 4 main languages. In California, there are 21 main languages. And there are still subgroups that, like, we don't publish it in Hmong, which is a language of Southeast Asia, even though it's a substantial population. So how do you do that? So it turns into a cost-benefit trade-off. Okay, so thank you for doing that. I hope that was useful. In general, I really like these little explorable things because they make these sort of abstract concepts very real. So we talked about those. Okay. This is worth looking at if you want to go look for some more AI resources, and including both the Google and the Microsoft AI fairness checklists, worth looking at. I want to end on a theme of AI gone bad in some ways. So you know that there are face recognition algorithms out there. If you use Facebook or Google Photos, any of these things, it will say, that's a photo of your wife, or that's a photo of your brother, or a photo of your whatever, right? It has face reco inside of the Facebook photos. It has face reco inside of Google Photos. So when I add a new photo, it says, oh, that's whatever, right? Tags it. This technology has been around a long time. But there's a company called Clearview. Anybody know about Clearview? Anybody? Couple. Okay. The security squad back there. It's great. So Clearview is a company that was set up a few years ago and providing global face reco. And so it not only recognizes faces, but will give you the name and the phone number, as much personal data as it has about that person. And this is actually a very good book. I highly recommend it, by Kashmir Hill, a reporter for the New York Times. That was funny. I didn't do that. So it's the story of how the company came to be, and it's interesting as an insider's look into how Silicon Valley companies sometimes start up. Where they ended up is they have this global database of faces. And you, as a company, could contract with them. You send them pictures, they send you IDs, right? And the problem with it is sometimes there's interesting problems in the data set. And what's so fascinating to me about this is that there's a great article in the New York Times about the technology of face recognition identification that both Facebook and Google have, and they did not release it to public use. So in some ways, Facebook has a fantastic database of pictures of people's names and faces. The problem is, in the US, there's been a wide regulatory movement to not allow police departments, military, and so on to use Clearview. So for example, where I live, the San Francisco Police Department says, no, that's illegal, that's too biased, forget it, you cannot use it. Well, I will tell you, they're using it. What they do is the cops in San Francisco will email pictures of suspects to their friends in the Phoenix, Arizona department where they don't have this problem. So if you're trying to regulate AI, always think about this. There are people who can figure out workarounds. And so the cops got slapped on that. Now they use different email addresses. Or they use WhatsApp. Or they use Telegram. Or they use something else, right? So the problem is you can regulate it locally. And it's also interesting to note that Clearview, the company, has been fined $20 million, 20 million euros by Europe. However, a recent judgment said, forget it, they don't have to pay that. But then another one, in September of last year, the Dutch Data Protection Authority fined them 30 million euros. This goes back and forth and back and forth and back and forth. In the meantime, Clearview continues to make money and continues to employ people, whether or not that's a good thing or not. But what I found really interesting, you remember Google Glass? Heads-up, head-mounted display. In the very first demo at Google, I was sitting in the audience, and that was actually one of the first demo applications was walking through the audience and looking at people and saying, who's that? And you could see in the display, it would identify the person because they have the image of everybody in the company, right? So it's a simple face reco problem for them. To Google's credit, a lot of the AI protection people said, what are you doing? What's wrong with you? And they stopped it. They never carried that forward. So Google Glass does not have that capability natively. Unfortunately, a kid at, I think, Harvard then figured out how to hack the Meta glass and now has face reco for a lot of people. It's not the same as Clearview, but there's a compelling video on YouTube where he's walking around Harvard Square and it's just seeing people and getting their face, their name, their information, if they have any publications, all that stuff, all the information that's publicly available. So what should we be learning from this? Containing AI technology is super hard. It's very difficult to regulate it, or rather, it's easy to regulate, it's difficult to get enforcement, right? So here's a prediction. They're never going to pay the Dutch all that money. And if they do, it will be like the cost of doing business. So if you become a regulator and you actually want to do something about this, 30 million is not enough. Yeah.
I want to ask, do you know what's the difference? Because back with Google Glass days, I think they coined the term glass holes.
Yes.
And
Yep.
with the Raven, they don't drill it, it's just normal to
Yeah, that's a really interesting point. So a glass hole, for people who don't know, is somebody who wears Google Glass in a social setting, and you don't know if they're recording. They don't know the other people in the room. So, for example, if I was wearing Google Glass, technically a little red light is supposed to come on when I'm recording or when I'm taking pictures of you. I will tell you, in reality, people put a little piece of black tape over that. So people try, but then there's workarounds. There are always workarounds. So yeah, glass holes are kind of the social response to that sort of thing.
Why did it happen back then that there was like an overwhelming response,
Yeah.
like
Yep.
nowadays it isn't?
Yeah, no, it's true. This is actually a really interesting socio-technical observation. When new technologies like that are first introduced, there often is a vast negative response to it. I can give you endless examples of this. When telephones were first introduced, people said, this is stupid. Why would I want a device in my house that can interrupt me any time of day or night? And after time, people got over that. It's true. You have a device that can talk to you any time of day or night. And before telephones were common, that was widely viewed as a terrible idea. People got used to it. So there's an accommodation to technology introductions like that. It's the same thing happening here. So what would you do? The reason I put this slide up is for you. If you're, a user experience engineer working for a large company, and they introduced face recognition, what would you do? Would you quit? This is the fundamental ethical question you have to answer, is what's your personal responsibility for this? Because at the end of the day, the ethics are the composite response of the company to difficult situations. And so I have been in meetings where I've seen people quit because they thought, what the company was doing was unethical. And if you're not willing to do that, then you have to think about what your ethics are, right? You have to think about what moral stance do you want to take about these kinds of things. And this is not the end. We are going to see more and more of this kind of thing coming up, right? So this is a revisit of one of the first slides I showed you, the outline of the class, outline of today's class. All the comments in red are things that I added because the outline didn't include it. And I thought those were essential to the course. Interesting question. When you ask a large language model to summarize, to reorganize, to present, what's it leaving out? And how do you know? This is sort of one of the interesting issues, the fairness issues, the ethical issues that are coming up with large language models. Okay, so there's our question for today. This might be slightly harder than the average one, but it's an important point for today, which is where do these bias effects come from? What's causing them? And do you remember? And if you don't remember, that's okay, but just think about what you're taking away. What's the cognitive effort you're expending at any point in the class? So if you have to go back and look at the slides, that's fine. But just, I'm trying to make you aware of what your attention level is and your memory is at each point in the lecture as we go through the day. Okay, so part, I guess, 3 of the ethics stuff will come in tomorrow's lecture when Ibrahim talks about explainability and how you get AI systems to give you explanations for why they're doing that ridiculous thing. And I had a really fun conversation, I will say, with Gemini yesterday, asking about explanations. And so the explanation lecture, I think, is a really great one. All right, I look forward to seeing you all tomorrow when you will explain to me how to make AI unbiased. All right, thank you.
Yes,